Hello everyone, welcome to our channel Off Campus. We have posted many videos under engineering mathematics and under electronics and communication engineering. If you haven't seen those videos still, kindly subscribe our channel Off Campus and click on the bell icon. Then only you will receive notification whenever we upload videos. Then if you haven't seen those videos still, kindly check with the playlist. Okay. In this video we are going to see in engineering mathematics. Under engineering mathematics we are going to see differential calculus. In differential calculus we are going to see the concept of maxima and minima of functions of two variables, and what is the procedure to find out the maxima and minima, and we are going to solve few problems in this type. Okay, then first one, procedure for finding the maximum value on minimum value or minimum values of f of x comma y. First one, the given function is f of x comma y. Second, find dou f by dou x and dou f by dou y partially with respect to, if the given function is f of x comma y, so it is only theoretical. Just go through these points first, then only we will solve the problems, we can understand better. Okay, first we will see the procedures. Okay, first the given function is in f of x comma y, find dou f by dou x and dou f by dou y and equate to 0 by solving these equation, dou f by dou x equal to 0 and dou f by dou y equal to 0. Find the roots of x1 comma y1 and x2 comma y2 etc. Okay, these points may be maximum or minimum points. Okay, now we need to verify this. Find the values for r equal to, in terms of r equal to dou squared f by dou x square. This is very important. S equal to dou squared f by dou x dou y by, and t equal to dou squared f by dou y squared at these points. Then fourth one, we need to find out RT minus S squared. See, RT minus S squared should be greater, if RT minus S squared greater than 0 and R less than 0. See, the conditions is very important. RT minus S squared greater than 0 and R less than 0 at a certain point, then the function is said to be maximum. See, maximum at that point. Then if RT minus S squared greater than 0 and R also greater than 0 at a certain point, then the function is minimum at that point. If both are greater than 0, the function is minimum. If RT minus S squared is greater than 0 and R is less than 0 which means that the given function is maximum at that point. Okay, then what is the condition? 4 different conditions. Third condition, what is that? If RT minus S squared less than 0 means for a certain point, then the function is neither maximum or nor minimum at that point. This point is also known as saddle point. This is also very important. Saddle point means neither maximum or nor minimum. For maximum and minimum, what is the condition? RT minus S squared should be greater than 0, either for maximum or minimum points. So, RT minus S squared should be greater than 0. Then R also greater than 0 means the given point is minimum. R less than 0, then the function is maximum. If RT minus S squared less than 0 means this is not a maximum or minimum, neither maximum nor minimum at that point, or otherwise known as that point is saddle point. There may be a chance of question, means what is a saddle point? Saddle point means neither maximum or nor minimum at that point. Okay, then what is the fourth condition? RT minus S squared, if RT minus S squared equal to 0 at a certain point, then nothing can be said. So, where the function is minimum or maximum, nothing can be said. This should be investigated. Further investigation is required. If RT minus S squared equal to 0, nothing. Okay, RT minus, I am again saying, we know that what is R, S and T, right? How to find out the points? Equating dou f by dou x equal to 0 and dou f by dou y equal to 0, dou f by dou x equal to P, dou f by dou y equal to Q, dou squared f by dou f of squared equal to R, S equal to dou squared f by dou x dou y, then T equal to dou squared f by dou y squared. Okay, then what are all the three conditions? See, If both are greater than 0, the point is minimum. Rt minus s square greater than 0 and r less than 0, it is maximum point. Then Rt minus s square means it is neither maximum nor minimum. That can be, point is known as saddle point. If Rt minus s square equal to 0, further investigation is required. Nothing can be, okay, nothing can be said whether it is maximum or minimum. We'll see. Then the maximum or minimum value is also termed as extreme value. If it is in the question asked to find out the extreme value means, which means that maximum or minimum value, okay. Then what is stationary value? A function f of x comma y is said to be stationary at a comma b at any point if dou f by dou x a b equal to 0, dou f by dou y equal to 0, the stationary value is f of a comma b. At some points this will be equal to 0. So, that point is equal to the stationary values. How to find out the stationary points? Simply equating this dou f by dou x equal to 0 and dou f by dou y equal to 0 and solve this equation, we can find out the stationary points. For that we need to know what is maximum point, minimum point, what is maximum, minimum, saddle point, and then what is that extreme point. In some question there may be a chance of to find out the extreme value. Extreme value is nothing but maximum or minimum value. Then what is stationary point? Okay, let's solve problems, we can get an idea. So first one, what is that? What is given at that point 4 comma 0? This is the first problem, right? At that point 4 comma 0, the function f of x comma y given as x cube plus 3xy square minus 15x square minus 15y square plus 72x attains. In options we need to find out whether it is maximum point or minimum point or saddle point. Fourth one is none of the above, okay. We'll solve. What is the given f of x comma y? F of x comma y is equal to x cube plus 3xy squared minus 15x squared minus 15y squared plus 72x. This is the function. Points are given as f of x comma y at 4 comma 0. First what we need to find out? We need to find out one thing, what is that? Dou f by dou x and dou f by dou y, then dou squared f, each and every term p, q, r, s, t, and then find out the r value substituting. We will see one by one. First we need to partially differentiating with respect to x. 3x squared plus 6xy squared, sorry not 6x, just 3y squared, sorry, differentiating with respect to x, 3y squared minus 30x plus 72, right, this one. Then we need to find out the dou f by dou y value. Dou f by dou y. Dou f by dou y, what is that? 6xy minus 30y, right, these two terms 6xy minus 30y, these two only with respect to y. Then we need to find out the dou squared f by dou x squared from this. Again with partially differentiating with respect to x, 6x, this term won't come, minus 30. Then I am writing here itself dou squared f by dou y squared. This is r, this is t, right. Again with respect to y, 6x minus 30, right. Then what we need to do? Find out the s value. S value is nothing but dou squared f by dou x dou y, which means that how can we write dou by dou x of dou f by dou y, right. So in dou f by dou y we need to differentiate with respect to x. See carefully, dou f by dou y we need to again differentiate with respect to what? X, okay. Then with respect to x, 6y alone, okay. This is s, we know that r, s and t, right. Then what is the condition to find out the maximum or minimum value, right? We need to find out whether it is, we know the condition RT minus S squared, okay, to find out RT minus S squared. So, we have given one point as 4 comma 0. So, what is R? First we need to substitute that point. R equal to, this is the condition, we need to verify whether it is minimum or maximum by using this condition. And one more thing, in some questions or in some textbooks there will be given as AC minus B square. The same thing alone, A instead of R, or C minus B squared also given, okay. The same thing, but the alphabet only changing, AC minus B squared, L equal to AC minus B squared also, okay. First we need to R in R substitute at 4 comma 0. What is 4? Instead of x comma y na, in place of x substitute 4, 24 in here, minus 30, what we will get? Minus 6. Then what is S? S at this point 4 comma 0, P or ST was 6y. Instead of 0 we will get 0 alone. For S value we are getting 0 only. Then what is T? T is nothing but what? 4 comma 0. This T value 4 comma 0. Again 6x minus 30, right? The same thing will come, minus 6. 6 into 4, 24 minus 30, we will get 26. This is R, S and T, right? R and S, T at the given point 4 comma 0. From this we need to find out two conditions, RT minus S squared, how it will be. So, RT minus S squared, this is R value, R is minus 6, S equal to 0, T equal to minus 6. RT minus S square means minus into minus 36 minus 0 squared, we will get 0 alone. So, RT minus S squared equal to 36, this should be greater, this is greater than 36, obviously greater than 0. Then what is the R value? R value is minus 6, na? R value equal to minus 6, which is less than 0. So, from this, see RT minus S squared greater than 0, comma R less than 0, then what is the point? The given point is maximum or minimum? Maximum, right? If RT minus S square greater than 0, R less than 0 means we will say this condition, RT minus S squared greater than 0 and R less than 0, right? The given point is maximum point. So, for this question, from the given point, the point attains the maximum value, option 1, okay. Then we will move on to the next problem. Stationary points of, we need to find out the stationary points. How to find out? Just we will see stationary points of the given function, okay. What is given? First I am writing this. X power 4 plus y power 4 minus 2x squared plus 4xy minus 2y square. This is the given function. Let it be f of x comma y, function of x comma y. What we need to do to find out the stationary points? Dou f by dou x, find out dou f by dou x and dou f by dou y and equate to 0, we can find out the stationary points for the given function, okay. I am just cross checking. X power 4 plus y power 4 minus 2x square plus 4xy minus 2y squared, okay. First we need to partially differentiate with respect to x. So, 4x cube minus 4x plus this term 4y, okay, this and this alone. Then we need to find out the dou f by dou y. Dou f by dou y is nothing but 4y cube plus 4x minus 4y. Then what we need to do, dou f by dou x should be equal to 0 to find out the stationary point, and dou f by dou y also equal to 0 to find out the stationary points. Then see this one equal to 0 na, then all are multiples of 4 in this two equations. So by reducing, what we will get, dividing by 4, x cube minus x plus y equal to 0. Let it be equation 1. Then y cube plus x minus y. I am just eliminating the constant 4, okay, equal to 0. So by solving these equation we can find out the points. So adding 1 plus 2, what we will get, 1 plus 2 equal to, so these and these get cancelled, plus x minus x plus y minus y, and then x cube plus y cube equal to 0, or x plus y equal to 0, or x equal to minus y. Okay, x equal to minus y. This is the x equal to minus y or y equal to minus x, whatever, both are same alone. Okay, then we need to substitute in the first equation, y in place of y substitute minus x and find out the x value. From that x value we can find out the y value. Okay, what is the first question, x cube, first minus x, what is plus y equal to minus x only, 0. Okay, so what is that, x cube minus 2x equal to 0. Then taking x as common, x square minus 2 equal to 0. So x equal to 0 and x squared equal to 2. Then x equal to plus or minus root 2 and x equal to 0. So what is the x value? We can find out 3 points, root 2 minus root 2. So this is the value for x. We know that x and y are just changing the minus sign, y equal to minus x. So how can we find y equal to, just substitute minus of these values, y equal to plus 0 minus 0 will give the same thing, then y equal to minus root 2 and y equal to plus root 2, minus root 2 plus, just changing the sign alone. Okay, this is a x and y value. How can we write the points, like see, this is the stationary points, right? Stationary points are, this is the answer, just equating dou f by dou x and dou f by dou y equal to 0, we can solve this. So 0 comma 0, root 2 comma minus root 2, then minus root 2 comma plus root 2, right? This is the stationary points for the given problem. So which one, 0 comma 0, root 2 comma minus root 2, minus root 2 comma root 2, this is the problem. Option 2 is the right option for the given problem. Okay, we'll move on to the next one. Then stationary points u equal to, stationary points of this problem, u equal to x cube. So we need to find out the stationary points for the given problem. U is the function of x comma y, u of x comma y equal to x cube y squared into 1 minus x minus y, this one. Okay, we need to find out the stationary points for the given problem. How can you find? Just find out the dou u by dou x and dou u by dou y, then equate to 0, we can find out the stationary points. First we partially differentiate with respect to x, what we will get. So this is also uv, right, like uv, right? See, u, this one, this is u v, uv multiplication, u dv plus v du. So both are function of x and y. So this one du, 3x squared, with respect to x now, 3x squared y squared, keep this as constant. Then we need to differentiate this one. When differentiating this term, first we are differentiating this term and this is constant, then we are going to differentiate this term. So in that, with respect to x, this alone, when we differentiating -1, so minus into this term alone, x cube into y square. So this should be equal to 0 to find out that what is that stationary points. Then dou u by dou y, the same thing, differentiating 2x cube y into 1 minus x minus y. Then with respect to y, minus, when we differentiate this term, we will get alone -1. So minus 1 into, what is this term, x cube y squared, right? X cube y squared equal to 0. So dou u by dou x and dou u by dou y equating 0. From that, what we can get by equating, first we need to equating dou u by dou x equal to 0. So equating this term 0, 3x squared y squared into 1 minus x minus y, equating this, go to that side, x cube y squared. So x cube y squared, now by cancelling what we will get, see, y squared and y squared get cancelled. So x squared, here x alone, so 3 into 1 minus x minus y equal to x. All this x come to this side and multiply inside, 3 minus 3x minus 3y, this minus x also come this side, equal to 0. By simplifying, what we will get, equation minus 3x minus x minus 4x minus 3y plus 3 equal to 0, right? Or say multiply by minus 4x plus 3y minus 3 equal to 0. This minus 3 will go to that side as plus 3. By multiplying minus sign, 4x plus 3y minus 3 equal to 0, I am just moving this minus 3 to that side as plus 3. Okay, let it be equation 1. Then this term equal to 0, 2x cube y, I am just copying here. Here 2x cube y into 1 minus x minus y equal to x cube y squared, this one. Okay, then by cancelling x cube get cancelled, y squared, y get cancelled, and then multiply by 2, what will 2 minus 2x minus 2y equal to y. Then minus 2x minus 3y plus 2 equal to 0. See, minus 2y minus y equal to minus 3y, right? Minus 2x minus 3y, this plus 2, all taking all one side. Okay, then multiply by minus sign, what we will get, 2x plus 3y minus 2, we can move that constant as plus 2 equal to 2. This equation be set, this is equation 2. By comparing this and this, so add 1 and 2, by solving 1 and 2 we can get the points, 2x plus 3y equal to 2, right? 4x plus 3y equal to 3, 2x plus 3y equal to 2. This is the equation 1 and 2. Just subtracting 2 from 1. So this will cancel, the 2x equal to 1, then x equal to half. X equal to what? Half. Then find out y. Then substituting this equation, so 4 into half plus 3y equal to 3. Then 2 plus 3y equal to 3, 3y equal to 1, 3 minus 2 1, then what is y? Y equal to 1 by 3. So what is the point? 1 by 2 comma 1 by 3. So what is the stationary point for the given problem? Stationary points is nothing but 1 by 2, this is the stationary points, comma 1 by 3. So 1 by 2 comma 1 by 3 is the stationary point for the given problem. See equation option 4. 1 by 2 comma 1 by 3 is the right answer for this problem. We'll move on to the next one. Next problem. What is that? If A is negative. See, if A is negative, if A is negative, then for the function u equal to x cube plus y cube minus 3axy, the point A comma A. Point also given, the function is also given, and one more point also given. What is A is negative? If A is negative, the given A and A only given na. For that, if the A value is negative, what is the point at that point? How the point will be, maximum or minimum or saddle or none of the above? We need to find out. First, we need to write the given function u equal to x cube plus y cube minus 3axy. So, what is the given point A comma A, and given one more point A is negative. So, these are all the important points. So, we can find out the points. We know that RT minus S squared and R value, we need to find out the points value. Okay. So, first we need to find out the what R, S and T. Then we need to find out the maximum or minimum. For that we need to dou u by dou x, differentiate with respect to x. So, what is given? Dou u by dou x, right? Dou u by dou x, 3x squared minus 3ay. Then dou u by dou y, differentiate with respect to y, 3y square minus 3ax, right? Then what is that? Again differentiating dou squared u by dou x squared is nothing but r. R equal to again with 6x alone, because it is function of y. Then dou squared u by dou y square equal to what? This is t, right? Then 6y alone. Okay. Then we need to find out the dou squared u by dou x dou y equal to s. So, dou u by dou y, in that equation we need to differentiate with respect to x. So, with respect to x we will get minus 3a. So, we know the value of r equal to 6x. At what point given? A comma A. A comma A. At r A comma A means x equal to A, 1 y equal to A. So, substitute x alone, x only available. Okay. So, 6 into A, 6a. So, then what is this is, then let it be, then this value t value, t at point, given point A comma A, 6y. 6y means substitute at y equal to A, we will get 6a. Then s value already nothing, A and at s equal to A comma A means if it is x and y, we need to substitute in place of x and y as A. Here nothing is there, just simply constant, so it will be minus 3a. Then what we need to find out? RT minus S square. So, RT minus S square nothing but this and this. 6 and this is R value. R T. Oh, 6a into 6a, what is that? 36a squared minus S squared. Minus S squared. This squaring this side we will get as, what is S squared value? 9a square na, plus 9a square. 9a square. 36 minus a minus 9, what is 27a square. Let it be. Then we need to find out the R value. We need to find out whether it is maximum or minimum. What is given? One point is given. A is negative. See, in this question, if A is negative, if A is negative, what is A squared? A squared will be the positive value. So, this will be greater than 0. Okay. If A is negative, this value will be positive only. So, RT minus A squared is greater than 0. Then R value we need to find out. R is nothing but 6a. 6a means if A is negative means in case of some negative value, let a is a minus 1, we will get minus 6 for example. So, minus 6 should be is less than 0, is always less than 0. So, what we can get from this? RT minus S squared greater than 0 and R is less than 0. If RT minus S squared greater than 0 and R less than 0, what is the point? The given point. What is the given point? A comma A and A is negative. The given point is maximum. So, the given point is maximum point, maximum at this point, okay. So, for this question, option is maximum is the right answer, okay. We will move on to the next one, we will see. The maximum value of, we need to find out the maximum value of f of x comma y. Some function is given. What is the function? F of x comma y, 2 plus 2x plus 2y minus x square minus y square. So, this is the function and given us the, this is a maximum value. So, we need to find out the maximum value. First, we need to find out the stationary point. From this stationary point, find out RT minus S squared. So, we need to check the given maximum value of this function. So, we need to check whether it is maximum or minimum from that stationary point, okay. From that stationary point, if it is maximum, just substitute that stationary point in that equation, we can find out the maximum value. We need to find out the maximum value from that stationary point. Let us see how to solve this. This is the given function f of x comma y. So, what is the first point? We need to find out the stationary points. So, dou f by dou x, what is that? 2, then minus 2x, right? Then dou f by dou y, then what is that? Dou f by dou y, 2 minus 2y. Then what is, how to find out the stationary points? Dou f by dou x equal to 0 and dou f by dou y equal to 0 to find out the stationary points. So, 2 equal to 2x, x equal to 1. Similarly, 2y equal to 2, y equal to 1. So, what is the stationary point for this function? 1 comma 1. Stationary point is 1 comma 1. Then we need to find out whether this, at this stationary point, the function is attain maximum or minimum, okay. We need to check if it is if it should be maximum, it should be maximum na, then we need to find out the maximum value. So, how to find out the maximum value, sorry, maximum, whether it is maximum. So, then dou squared f by dou x squared, differentiate with respect to x again in this term minus 2 alone, okay. Then dou squared f by dou y squared, from this one also minus 2. Then what is the procedure? Dou squared f by dou x dou y, dou f by dou y with respect to x, no term with respect to x, so the differentiation is 0. So, what is that? R T, yes, right. From this RT minus S squared and R value, we can say whether it is maximum or minimum. So, this is R now. So, at this point, stationary points also given, we need to substitute at this 1 comma 1, dou squared f by dou x squared at 1 comma 1 at 1 comma 1. See, this is all three are constant. So, if it is a function of x and y, we can substitute in place of x and y as 1, this one, x equal to 1 and y equal to 1. Now, this all are constant. So, we need to find out the R value. I am writing very clear, R minus 2, then T also minus 2, then S equal to 0. So, we need to find out the RT minus S squared. So, RT minus S squared, just multiply 4 minus 0, 4 only. Then what is the, this is greater than 0. So RT minus S square greater than 0. Then what is R value? R value is minus 2 less than 0. So RT minus S square greater than 0 and R value is less than 0 is, this is maximum at that point. At that stationary point the given function is maximum. So what is the 1 comma 1 na? Stationary point is 1 comma 1 gives maximum, which means that this therefore this point stationary points gives maximum. Then what is the maximum value? We need to find out the maximum value of f of x comma y. So we need to find out the maximum value of f of x comma y. What is f of x comma y? 2 plus 2x plus 2y minus x squared minus y squared. I am writing here. What is that? 2 plus 2x plus 2y minus x squared minus y squared at which point? 1 comma 1. So substitute 2 into 1 2, 2 into 1 2, again minus 1, okay. So 6 minus 2, what we will get? 4. So maximum value is equal to 4. Maximum value equal to 4 for this problem. So option 3, 4 is the right answer for this problem. Okay, we'll move on to the next one. Okay, this video is or otherwise we can end up to this. This video is going very lengthy, so I will end up this video up to this. We will solve remaining problems in our next video. Okay, see, please subscribe our channel Off Campus and click on the bell icon. I will upload this as part 1 and part 2 will be coming soon. We can solve more problems in this type. Okay, thanks for watching.